All right, so today we are going to look at section 1.5, and it's on transformations. Basically, a transformation is when you just take a function and you either move it up or down, move it left or right, stretch it, or you could compress it, or flip it. Okay, those are the different transformations that we'll look at. We're going to study transformations specifically of quadratics, but once you know how to do transformations, they apply to every function we're going to study all year. Okay, we're going to study probably 6 or 7 different types of functions, and the transformations are going to be the same every single time. Okay. But for today, we're just going to look at quadratics. All right, so what is a quadratic? That's generally what a quadratic looks like. It's an equation that looks like ax squared plus bx plus c. The a, the b, and the c can be any number that you want, positive, negative, fraction, or decimal, except a can't be 0. What would happen if you filled in a 0 for a right there? I think they know what would happen if you filled in a 0 for a. Yeah?
X squared would be 0.
Yeah, this whole term would get wiped out. And what would you be left with?
Bx plus c.
Which is not quadratic, that's just linear. Yeah. So if you make a 0, you effectively wipe out your quadratic term. It's gone. So it's not a quadratic. So a can't be 0. All right, let's try graphing y equals x squared and see what it looks like. Okay, if you've got anything else in there, just go ahead and clear that up. Type in x squared. And whenever we want to start with our window, we always do zoom. What's the zoom we do? Yep.
-10, 10.
Yeah, and what do we?
Standard.
Yeah, it's standard. So zoom 6, standard window. Okay. So, so there's our graph. That is a quadratic. Can someone remind me what that shape is called? Yep. Yep, that's a parabola. Good. Now I want to do something to that. I want to leave the one that I have now. But I want to go down to y2. And I want to put in parentheses negative x squared. So what I'm doing now is I'm replacing the letter that we had with negative x instead of positive x. I'm still squaring it. I want to know what happens when I put in a negative.
It's the same.
Yeah, it looks exactly the same. Watch it trace over it. The negative technically did something, okay? But what do you think the negative did? But you can't tell because this graph is symmetrical. The negative did do something though, yeah?
Was it like a depth thing? Like a, I don't know. I'm not quite sure.
No, not a 3D thing. No, it didn't do anything 3D. Anybody have a guess what that negative did, but you can't see it because the parabola is symmetrical? Yeah?
It stretched it.
Well, if it stretched it, we would see it look different. So it didn't stretch it. It's still exactly the same width that it was before.
Just longer?
No, it's not longer because it traced exactly over it and it goes on forever. We can't see it go on forever because it goes off the screen.
And what did it do?
Anyone have another guess what the negative did? Yeah?
It went down a little bit.
No, it didn't go down a little. It is exactly in the same spot it was the first time. It's an identical picture to the original. Yeah?
It flipped it.
Yes, it flipped it. How did it flip it?
Started on the other side that it started on.
So think about maybe like in terms of an axis. Which axis did it flip it over? Yeah. What that negative does is it flips it over the y-axis. Yep, flips over the y-axis. Because a parabola is symmetrical, you can't tell that it's been flipped. All right. Most graphs, well, a lot of graphs aren't symmetrical, and then you can't tell. So when we talk about transformations, I want you to kind of get the idea that when you see a negative usually causes something to reflect. Okay. So when you draw a parabola, the way we did, the y-axis is called a line of symmetry. A line of symmetry is a line, like if you learned from geometry, that if you flip it over that, it should look identical. And that's what we did with the parabola. It looks identical. Anybody know what the name of that low point is at the very bottom of the parabola?
The vertex?
Yep, that's called the vertex. And the low point, or in this case it's a low point, it could be the highest point if you take the parabola and flip it. But that point on a parabola, that is called the vertex. So what we're going to do is we're going to take, let's hear. We're going to take the basic parabola and we're going to change one thing at a time and see what it, we're going to change one number at a time in the formula and see what does that number do. If we change too many numbers at once, then we can't tell what's happening. So we're going to just change one thing at a time. And the first thing we're going to change is the number in front of x squared. So we'll try leaving it as x squared. Then I want to try putting in a 1/3 in front. Then I want to try putting in a 2 in front. And my goal is to figure out what does changing that number in front of x squared do to the graph. All right, so if you have x squared, leave that one. The way you can type in 1/3, there's a couple ways you can do it. That's how I do it. 1/3 x squared and 2x squared. All right, let's graph those and see what they look like. Okay, that's the original. The next one in red, this is the 1/3 x squared. And then the one in black you're going to see in the middle, that's the 2x squared. What's the difference? What happened when we changed that number in front of x squared? What did it do to the picture? But Alejandro, what do you think? What did it do?
I was not listening.
All right, I need someone that was listening. I need some help here. Yeah. Yeah, it changed, it stretched or compressed the graph. Okay, so you change that number in front of x squared, it's going to cause the graph to stretch or compress. Okay, and what we want to do is think about it vertically. Pretend like the graph in blue is glued down right at the origin. If it was glued down at the origin, you grab the sides of the blue one and you pull it up on it, it would get taller and skinnier. Likewise, if that graph in blue was, again, glued down at the origin and you pushed down on it, it would look like the red one. It would spread out. Like imagine you had clay and you push down on it, it's going to squish out sideways. So what happens when we change A is we either get a graph that stretches. The higher you make this number, the more stretch you're going to get and the skinnier it's going to look. Think about if you took a person and like stretched them taller, right? They get skinnier. Stretch out tall, you get skinny. And then the smaller you make that number, the more squished it starts to get. And when it starts squishing, that's when it spreads out horizontally. So these are the two ways we'll explain it. The graph either is going to stretch vertically or it's going to compress vertically. Okay, what if I did, I'm going to do one more graph. Let's do like 8x squared. Do you think 8x squared is going to look more stretched than 2x squared or not as stretched?
No.
Yeah, it's going to be even more stretched. So that pink one is going to be very skinny in the middle because I've stretched it out even further. Yep. And more and more you stretch it, the skinnier it starts to get. Okay, how about if I did, instead of 1/3, let's say I did something like 1/10. How do you think 1/10?
It's going to expand.
Yeah, it's going to get really wide because 1/10, you think about you squished it. It's like you squished it down 10 times as much. So look at how wide this one is. Okay, squished it way down vertically, so that's why it looks the way it does. Okay, so any questions on what changing that number does? All right, so let's still stick with A, except this time, instead of just changing the number, I also want to make it a negative number and see what that does. Earlier, I said that when you put a negative in, it usually causes your graph to do what?
Flip.
Yep, causes your graph to flip. Now, when you draw a graph, how many different axes are there? 2. So you can either have something that flips over the y-axis. That's an example of the y. Or you could have something that flips over the x-axis. That's over the x. Which axis it flips over is depends on where you put the negative. So there's a difference between doing this and doing this. One has the negative in front, the other one has the negative inside the parentheses. We already looked at the negative inside the parentheses. That's the one that I did right there. What I want to look at this time is when you put the negative in front. Okay, let's see what happens. Right, so if you have other graphs in there, we can clear all these out. Right, and let's type in, again, no parentheses, just the way it looks right there. Negative x squared. Negative 1/3 x squared. And this is how I would do negative 1/3. Just like that. And negative 2x squared. When I hit graph, what do you notice about the way all of these look compared to all the other ones I just drew?
They're upside down.
Yeah, they've all been flipped. Which axis did they flip over?
The x-axis.
Yeah, they all flipped over the x-axis. The width changed too. The number, like the 2 and the 1/3, that's compressing and stretching it. The negative is flipping it. So there's actually 2 things happening there. Stretching or compressing and flipping. So the negative causes the graph to open down because it reflected over the x-axis.
Can you show what the graph looks like?
Yep. They all look like that. They all open down. So that's pretty much what changing the number in front of x squared does. Stretches and compresses it, and if it's negative, it flips it. All right, so what kind of questions are we going to see? What I'm going to do is I'll give you an equation, and I'm going to ask you, how can you get this starting from that? Okay, and the first step is to just kind of think about how many transformations do you think it would take to change this into that? How many different things do you think are happening? Yep. Yeah. It's going to take 2 steps to change that into that. Now, the order that you list the steps in is important. I'm not going to talk about the order right now. I'm just going to kind of lead you through the question, and I'll tell you the order later on. So the first thing we want to do is start with the 5. When you have a 5 right in front of x squared, can anyone explain to me what that 5 is going to make your graph do? I think, yeah.
Compress it.
So look right there. What's the value in front of x squared in this one? It's 5. What happens if a is 5? Stretches. Okay. A is bigger. 5 is bigger than 1. So the graph is going to stretch. Okay. This is how you write down what's going to happen. You put vertical stretch by a factor of 5. That's what the 5 does. Vertical stretch by a factor of 5. Okay, second thing. Second thing is this negative. Can anybody tell me what the negative in front of the 5 is going to do? And remember, this is a negative in the front. So we talked about which axis it's going to flip over. Yeah?
The x-axis.
Right. This is going to be a reflection over the x-axis. That's what we just did right up above. So to describe that, you literally can just say reflect over x-axis. That's all you need to say. And that's it. Those are your 2 transformations. Any question how we got those 2 transformations from, bless you, that problem? All right, so we've done about everything we can do with changing that A. Let's try changing something else. Instead of multiplying by the number in front of x squared, now I want to look at adding and subtracting. Does anybody have a guess what this plus 2 would do to the x squared function? Yeah.
Is it going to change where it crosses the y-intercept?
Okay, so yeah, it is going to change the y-intercept. What kind of transformation do you think the plus 2 is going to do? You don't have a guess on that one. Yeah, William?
Like raise the vertex.
Okay, so move it which way?
Up.
Up? How many?
2.
Okay, so yeah, that is what's going to happen. It's going to move it up 2. And we can test it just by graphing it. Put x squared in, and then put in x squared plus 2. just like that. So take both of those and hit graph, and then see what it looks like. Okay, that's the original. And there's the one that's been shifted up to. All right, so let's write that down. So how do you get that? So y equals x squared plus 2 is shifted up 2 from the original. Okay, so that's that one. What do you think about x squared minus 3? Yep.
It's going to go down 3.
Yeah, it's been shifted down 3 from the original. Yep. So y equals x squared minus 3 is shifted down 3 from the original. What do you think makes the difference whether it's going to shift up or shift down? Yeah, if it's negative, it's going to shift down. If it's positive, it's going to shift up. So this is an example of what we call a vertical shift. Whether it's up or down, that is vertical. Vertical shifts, if you learned them in geometry, you might have learned as like a translation. It doesn't stretch the graph at all. It just takes and moves it somewhere else. And what we have to remember is which way it's going to move. If the number that you put at the end is greater than 0, plus 2, plus 3, plus 6.5, it's going to shift up. If the number that you put on the end is less than 0, okay, negative 2, negative 10, negative 3.6, it's going to shift down. Notice I put absolute values here. When you describe something shifting down, don't say that it shifts down negative 2. It can just say down 2. Okay, down is the negative. So it can shift up 2, it can shift down 2. But it can't shift down negative 2. Okay, down is negative. And if something's been shifted a lot, let's say it's been shifted a couple hundred units, then it could be way off the screen, and then sometimes we have to find it. And that's probably one of the tougher things on the calculator, sometimes figuring out where your graph is when it's way off the screen, like hundreds of units off the screen. But we'll practice it. All right, example 4. So example 4 is still adding and subtracting, just like example 3. But does anybody see what's the difference in terms of how I'm doing the adding and subtracting here versus how I did the adding and subtracting in that one? Yep.
So the result's going to be like attached to the exponent instead of the x.
So where is the adding or subtracting now?
In the parentheses.
It's in the parentheses. What kind of direction do you think these are going to shift in? When you add or subtract in parentheses.
Lower?
Well, give me like a direction.
Down?
Well, down we already talked about over here.
Oh.
So down is from example 3.
This is left or right?
This is going to be shifting left or right. Let's try one and see what you think. Let's do x minus 3. So leave the original. What way do you think x minus 3 would shift?
Left.
You would think it would shift left 3 because like on the, negatives go to the left. You would think that. Yeah?
It's going to go to the right.
Yeah, it does go to the right. So there's the original in blue. It's going to go right through the origin. And the one in red is going to be moved to the right 3 units from doing the -3. So this one is kind of backwards. It's still a shift. It's not stretching it in any way. Oh, I'll answer the question too. How can we get, so y equals x minus 3 squared is shifted to the right 3 units from the original. I'm not going to write the other one down, but what do you think about x plus 2?
It's gonna move to the left.
That one would be left 2 units from the original. Yep. So somehow we got to remember that this one is backwards. Right? There's different ways you can remember it, but this is how I remember it. If you have plus a number, like if h is greater than 0, plus 3, plus 4, plus 10, plus is going to shift it left. If h is less than 0, -2, -10, -50, a negative number is going to shift it to the right. So positive numbers shift left, negative numbers shift right. And mixing that up is something people do all the time. They mix it up. So when you draw a parabola and you don't do anything to it, just draw this one. Does anybody remember where the vertex was? Yep. It was right on the origin. Now, let me do this. What's the -3 going to do? Which way and how much? Yep.
Right 3.
It's going to shift it right 3. What's this +1 going to do?
Shift it back.
Up 1. This is right 3, up 1. If you had a point at the origin and it went right 3 and up 1, where would it be after you did that? 3, 1. So these two numbers, the one after the minus sign and the one at the end, give you the coordinates of the vertex. That's how you find the vertex. So let me write that down. H. Okay, and let me highlight the two things that tell you the vertex. Just what I highlighted in green, not the minus, just the H, and this whole thing. If you write down the two things that I highlighted in green, put a comma between them, you'll automatically get the vertex. So it's the number after the minus and the number at the end. And the other thing that changes, if you shift left and right, you're going to move the line of symmetry. Bless you. The line of symmetry only depends on the h. K shifts up and down. Think about if you had a parabola like this, and you shift it up. Did the line of symmetry change when I shifted it up?
No.
No. That's why K has nothing to do with line of symmetry. It's only if you shift left and right that the line of symmetry changes. All right. So let's see if we can use that formula to figure out the vertex and line of symmetry for that picture. All right. First thing, does this look exactly like what I wrote right there?
No.
Not quite. There's something, especially inside the parentheses, that's a little different. Yeah, it's a plus. I told you that you need to look at the number that's after the minus sign. So how could I think of that
Oh,
as x minus, and then tell me a number to put right there? Yep,
-2.
exactly. -2 and -3. Now, if I highlight it in comparison to what we had, that is the h. This is the k. Green on green, probably not the best highlighting, but I think you can still read it. Okay, so what do you think the vertex would be?
Two, three. -2. Negative, sorry, -2.
-2 and
-3.
-3. Yep. You went left 2, down 3. Think if you started at the origin, which is where it would have been, and you go left 2, down 3, that's where you end up. Okay, line of symmetry, that's a vertical line. What letter do we always start with for a vertical line? Yep, x equals, and what number would go on the other side? -2. It's the number that's after the minus sign. -2. So that's how you find the vertex and line of symmetry for a parabola. Any question on that one? All right. So now I want to describe the transformations here, but I got to start to talk a little bit about the order. The reason the order matters is, well, watch what happens. Let's pick a number for x. Let's say x is 2. I want to multiply by 5 and add 4. And let's do it 2 different ways and see if we get the same answer. If you take the number 2 and multiply by 5, what do you get? 10. And then add 4, you get 14. Now let's add 4 first. If you take the number 2 and you add 4, what do you get? 6. Now multiply by 5. 30. It's not the same thing. So if you don't do the transformations in the right order, you won't get the same answer. So what is the order? That's the order. There are 6 things that we're going to talk about when we do transformations. In this section, we're only doing 4 of them. The 2 that we're missing would go right in there. We are missing horizontal stretch, and we are missing reflection over the y-axis. I'm not doing those 2. We're not doing reflection over the y-axis. We already talked about that. When you reflect a parabola over the y-axis, it looks exactly the same as when you started. That's why we're not doing that. So when you describe transformations, that's the order that you want to follow. Start with the horizontal shift. Then the next thing would be any vertical stretching or compressing. Reflections over the x-axis. So for this one, you'd be looking for a negative in the front. And the last thing you look for is any vertical shifts. That would be adding or subtracting a number on the end of the problem. Horizontal shift would be adding or subtracting a number inside the problem, inside the parentheses. If you are missing one of them, then you just skip it. So let's look at example 6. How many transformations would it take to change that into that? Have a guess. Yeah, what?
4.
Okay. You tell me, what are the 4 numbers that are involved that would change this into that?
Oh, wait, no, it would just be 2, right?
Yeah, it would just be 2. There's only 2 numbers there, so there's only 2 things that are happening. 2 out of the 4. Which one do you think we start with? The 5 or the 4?
5.
Yep, we're going to start with the 5. The 5 is when you multiply by a number in front of x squared. It's the very first one we did. Does anybody remember what putting a number in front of x squared does?
Like just squaring it, or what do you mean?
So what would be, if you have to describe the transformation, what does the 5 do?
I don't remember.
You multiply 5 by x.
So it's got to be one of the things we wrote down. Is it a horizontal shift left, horizontal shift right, vertical shift up, vertical shift down, vertical stretch? What is that 5?
It's like the vertical stretch.
That's a vertical stretch, yep. When you put a number in front of x squared, in this case it's a 5. We did a 2, but when you do a 5, it's going to stretch the graph. All right, how do you write that down? So the first thing you want to write down is it's a vertical stretch. And then you have to tell me how much. Okay. So vertical stretch, you all set, Jim? Okay, can you, rather than take a picture, can you just write it down for me? Okay. So vertical stretch by a factor of 5. Or it's online too. It's on YouTube. Okay, so that's the first time. Vertical stretch by a factor of 5. What's the other number in that problem we still need to deal with? Well, yeah, the plus 4. What does adding 4 on the end, what does that do to it? Adding a number on the end. Well, it's definitely after vertical stretch because we have to do them in the right order. So it's either 3 or 4. Yep.
It's a vertical stretch.
Yep. And plus 4 is going to move it which way?
Up.
Yep. Shift up. Perfect. All right, let's try another one of those. First thing, how many transformations are in this problem?
Would be 2.
More than 2.
Would it be 3 because there's 3 in the first column, or what?
No, it's 4.
There's 4.
Where?
Every one of those transformations is in this problem. The plus 4 does something. The minus 1 does
Oh, I
something.
didn't even see the plus 4, sorry.
3 does something. and the negative in front of the 3 does something else. So you got every one of them. Well, since we have every one of them, let's start with the horizontal shift.
Hey, do we gotta go?
Yeah.
Okay. What number there is going to be your horizontal shift? Yeah.
Is the homework gonna be online or?
Yep, it'll be online. Yep. Brett, what number there is your horizontal shift?
-1.
The -1. Yep. And which way, Alejandro, which way is -1 going to move the graph?
Would be
To the right. So shift right 1. Okay, next one, vertical stretch or shrink. Kyle, what number there is going to be the vertical stretch or shrink?
-1.
Already used the -1. That's shifting right 1.
3.
The 3. Yep. How do we describe the vertical stretch when there's a 3 here? What's that sentence I used to describe the vertical stretch? Yep. Yeah, vertical stretch by a factor of 3. Vertical stretch factor of 3. Okay. The next thing is the reflection. And then we just have to write that down, reflection over the x-axis. What's causing the reflection in this problem? Yeah. The negative.
3.
Yeah, negative in front of the 3. Reflect over x-axis. And the fourth thing is the vertical shift. Natalie, what's causing the vertical shift there? The +4. Yep, and that's going to shift it which way? Up. So shift up 4. Not every problem has every single transformation like that. This one did. Okay, so every problem we've done so far has been in standard form. So the spaces you have to look at for your transformations are, look in the front, look at the number inside after the x, and then look, is there something added or subtracted on the end? That can give you one transformation. That can give you one. This one can give you 2 if there's a negative with the number. Okay, and every problem that I give you will always be in standard form. Okay, I'm not going to give you one that's not set up something like this. The last thing. So the last thing I want to talk about is when you draw a quadratic. Can someone remind me again, what's the shape of it? Yeah?
A umbrella.
What's the, yeah, parabola. How many times when I draw this can a parabola cross the x-axis? What would be one case that could happen? Yep. Could cross twice. Whether it opens up or down. Okay, could cross twice. What else could happen?
Once.
Yeah, it could just be once. Maybe if it did something like that. What else could happen? Yeah.
It could hit no time.
Yeah. Maybe it does something like that and it doesn't hit at all. Everywhere that it hits the x-axis, that's called a 0. That's what it's called. Let's call it an x-intercept, but you could also call it a 0. So, if you have an equation, remember what a quadratic equation looks like. Let me try to go back. All right, so we wrote it as ax squared plus bx plus c. What I want you to remember is where the a, the b, and the c are. A is in front of x squared, b in front of x, c is at the end. If you want to quickly figure out how many times does your graph cross the x-axis, and remember we said it could be 0 times, 1 times, or 2 times. You can figure out how many times it crosses very quickly by doing this calculation. B squared minus 4ac. Depending on what that comes out to. Okay, so you take that number, and that number. If that comes out less than 0, then your graph will never cross the x-axis. If it comes out to exactly 0, your graph will cross once. So it doesn't even really cross it. It kind of looks something like that. And if b squared minus 4ac comes out bigger than 0, it's going to tell you that your graph crosses twice. What it doesn't tell you is where it crosses. If you want to know that, you got to do the whole quadratic formula to figure that out. But if you just want to know how many times would this graph cross the x-axis, this calculation will quickly tell you that. Any question on that? All right, so that's 1.5. So let me just double check homework. To fix the last couple. It's 44 and 46. Right, so that's the homework, just this part on page 56. So we'll take a look at that tomorrow, no test tomorrow. I will also be after school for extra help. If anybody needs help with anything, calculator stuff, whatever you need help with.